Hello children. So let us proceed our chapter Matter in Our Surroundings. And in our previous lecture we have learned that temperature and pressure modulations can bring about the change in the state of matter. Today we will be learning more about it. So the question is, can matter change its state from solid to liquid or from liquid to gas? Yes, it can. And the best example is water, because we have seen that water exists as liquid. It is also found as ice and in vapor state as well, which is the gaseous state. So how does this change of state take place? And what happens to the particles? Because we have learned that particles are almost fixed in solid and they vibrate a little in the liquid state, and they are very much free in the gaseous state. So we will be learning about particles and what happens to their force of attraction holding them together when the change of state takes place. Now, change in the state of matter can be brought about by modulating temperature and pressure. And in today's lecture, we will be learning about the changes in temperature and what effect do they have on the state of matter. So let us recall this activity where few ice cubes are put in a beaker and they are provided with continuous heat. So this beaker containing ice cubes is kept upon a tripod below which a burner is continuously on. We also have a stirrer so that we keep stirring the whole thing so that whatever the temperature is uniformly distributed, and this thermometer measures that temperature. So there comes a time when ice starts melting and we are constantly monitoring the temperature, and till that point when all the ice cubes have completely melted, the temperature keeps showing 0 degree. Why? Because once the ice has changed into water, it should start changing the temperature as well, because we are continuously keeping the burner on. But that is not the case. Unless entire amount of ice is melted, the temperature does not budge from 0 degree. Why? Because heating of ice cubes is being done as following. When we increase the temperature or we keep providing the kinetic energy to the particles, that energy is going to be utilized in increasing the movement of the particles. Okay, now as the movement of the particle increases, so the force of attraction will be overcome or weakened. So in the solid state, the force of attraction is the strongest. We have to overcome this force so that the particles can leave their fixed position and behave as they behave in the liquid stage, and they can start moving more freely. So whatever heat we were providing was actually being utilized in weakening this force of attraction, and that is why, children, till the entire bulk of ice was melted, there was no increment in the temperature. So slowly a stage is reached when the solid is completely melted and converted to liquid. So once this stage is reached, only then we will be observing the change in the temperature. Otherwise, that ice and the melted water, the water that has been formed by melting, both will be existing at the 0 degree. So what does it tell us? The minimum temperature at which a solid melts to become liquid at the atmospheric pressure is called the melting point. So the melting point of ice is 0 degrees Celsius or 273 Kelvin. Also, the process of melting, which is the solid state changing into the liquid state, is known as fusion. So this phenomena can be asked with the term melting or the fusion. Let us move ahead and understand a few more concepts. Latent heat of fusion. So fusion is melting, and as we have just discussed that the temperature of the entire content of the beaker did not change till the point all the ice was melted. So we were continuously providing the energy from the burner. Where did that energy go? It seems like it was hidden somewhere, and that's why we call it latent heat of fusion. So when a solid melts, its temperature remains the same as we discussed, and when the ice is melting, the temperature of the system is not changing till all the ice is melted, because though we continue to heat the beaker, that extra heat is used up in overcoming the forces of attraction between the particles. And since this heat energy is absorbed continuously, but there is no rise in temperature, so it looks like it is getting hidden somewhere. So that is known as latent heat. And since this is the phenomena of fusion, so we call it latent heat of fusion. So particles in water at 0 degrees Celsius or 273 Kelvin will have more energy as compared to the particles in ice at the same temperature. So children, remember, the phase when both ice and water are coexisting in the beaker, both are at 0 degree. So the temperature is same, but the water molecules have absorbed the extra energy, which was the latent heat, which was used to overcome their forces of attraction. So obviously the water molecules, water particles have more energy as compared to the ice particles, though both are having the same temperature. And that is where the latent heat goes, in increasing the kinetic energy of water particles. I hope this is clear. So let us move ahead and learn some more concepts of change in the state of matter. So after learning about solid to liquid change, we are going to talk about liquid to gaseous stage. That is, when we heat water, liquid water, it vaporizes. So we are going to talk about vaporization. When we are supplying heat energy to the water, so whatever the room temperature is, it will start heating up from that temperature. And when we are providing energy in the form of heat, we are actually increasing the kinetic energy of the particles, so they will start moving faster. And then there comes a certain temperature when the particles have enough energy to break free from each other. Now there is not even that weak force of attraction that the liquid shows. Now they have broken free and they are free to randomly move about just anywhere. And this is the property of gaseous state, if you remember. So at this temperature, when the particles are starting to break free from each other and they have completely overcome their forces of attraction, this temperature is when the liquid starts changing into the gaseous phase, and that's when you see the vapor starts rising from the water containing beaker. And the temperature at which a liquid starts boiling, that is when it is continuously changing into the gaseous phase at the atmospheric pressure, is known as its boiling point. So just like the melting point, this point is also important to remember. And particles from the bulk of the liquid actually gain enough energy to change into vapor state. So you will not observe that only one particle at a time is going into the gaseous phase. No, bulk of particles gain that amount of energy and bulk of them start changing into the gaseous phase. So this is vaporization, and this happens at the boiling point. So what is latent heat of vaporization? Let us try to understand this also. So if we see this setup where the water at room temperature was provided with constant amount of energy, and slowly its temperature will start rising from the room temperature, and after a certain point it starts boiling. Now what is that temperature? So that temperature is 100 degrees Celsius or 373 Kelvin. So we were providing continuous amount of energy. Initially the temperature of water started rising because that energy went into increasing the kinetic energy and weakening the force of attraction between the water molecules. So if the molecules are not held together by a strong force, they will break free from each other. And this is exactly what happens at the 100 degrees Celsius or the boiling point, that molecules start breaking free from each other and start changing into the gaseous state, and that is what we observe like vapors. So the temperature at which water starts changing into vapor phase is 100 degrees Celsius or 373 Kelvin. Now particles in steam are also at 100 degrees Celsius. So if you measure the temperature of the boiling water and the vapor it is producing, both will show you that the temperature they have is 100 degrees Celsius. Still, the gaseous particles or the vapor particles have much more amount of energy than the liquid water at the same temperature. Why? Because the steam particles or the vapor particles have absorbed extra amount of energy in the form of latent heat. Just like in fusion, we observed that ice and water, despite being present at 0 degrees Celsius, the water molecules were showing more amount of energy because they have absorbed latent heat of fusion. Here also, when the phase changes, the phase change happens because particles have much higher amount of energy in the gaseous phase, and that energy which they have absorbed to increase their kinetic energy is latent heat, and that's why the temperature is not changed. The temperature of boiling water and the vapor both is 100 degrees Celsius. Is still the steam particles contain much more amount of energy in the form of latent heat. So let us summarize all of this. When the solid changes into liquid, we need to provide heat, and this is fusion. When the liquid changes into solid, we need to lower the temperature or remove the energy from the system, which is solidification. When liquid changes into gaseous stage, we need to provide heat, and this is vaporization. When gases need to change into the liquid stage, this is condensation, and we need to remove the energy from system. So we can infer or conclude that the state of matter can be changed into another state by changing the temperature. Let us see another phenomenon. So far we have seen this stepwise change, that solid to liquid and then liquid to gaseous. Now we are going to observe something different. So let us see these different compounds. This is camphor, that is generally used in religious rituals, and these are naphthalene balls that are also known as moth balls. This is dry ice or solid carbon dioxide, which is used for packaging and sending the material for long distances when the temperature needs to be maintained at very low degrees. And this is ammonium chloride, a salt. So why am I showing you all of this? Because children, these are certain compounds which either at normal temperature or at high temperature will directly change from solid to the gaseous phase, that is, they will evaporate. There will not be any liquid stage in between. So those compounds which show this kind of phenomena are known as sublimating substances. So what is this? These compounds will change directly from solid state to gaseous state, and its gaseous stage will directly change back into the solid stage if the temperature is lowered, but there will not be any liquid stage in between, and this process is known as sublimation. So the examples of compounds that show sublimation is camphor, naphthalene balls, ammonium chloride, and dry ice or solid carbon dioxide. Now what happens in this? That these solids might be having weaker force of attraction in their solid stage, so their solid to gaseous transition is easier. Now there is reverse process to this as well, because in your activity you might have seen that ammonium chloride when heated directly changes into the gaseous stage. But if you prepare a setup where you can trap those vapors, then they will deposit back into the solid stage of ammonium chloride. So when the phase transition, when a gas is converted directly into solid without intervening liquid phase, this is exactly the reverse process of sublimation, and this process itself is known as deposition. With this, children, we have completed the effect of temperature change on the state of matter. In our next lecture, we will be talking about the effect of changing pressure on the state of matter. After that, we will also discuss what is evaporation and what are the factors that govern the rate of evaporation. That will conclude this chapter, which is matter in our surroundings. So please revise till these topics and come prepared for the next lecture. Thank you.